Alrighty, guys. So today we're going to be talking about unknown companion stars today, really. There's one kind of a theoretical companion star theory that's gaining traction regarding Betelgeuse. And we're going to be talking about a brown dwarf that was just recently discovered to actually not be just one brown dwarf, but actually kind of a binary system of like two twin stars. So, yeah. And then for our Sky Report this week, we're going to be talking about the new moon as well as many other celestial and heavenly objects that are going to be up in the night sky. Anyways, all that and more will be covered. This is Interstellar Insights. Alrighty, guys. So, starting off today, we're going to be talking about Betelgeuse. Like I said, there's been, what's the word? Man, I'm tired today. There's just been a lot of new discoveries going on regarding stars. So actually, compared to some previous episodes, sorry, I'm yawning. Where we talked a lot about black holes and all that jazz. We're going to be doing the same thing, except we're going to be dealing with stars, and they're actually very similar topics. But anyways, I digress. We're starting off with Betelgeuse. So, of course, Betelgeuse is a red supergiant. It's on the verge of becoming a supernova, exploding, and, we'll all see it, all that kind of stuff, and it'll be quite the event. So, yeah. But, excuse me, Betelgeuse is also really popular with astronomers because there's a lot of peculiarities with the star, such as with the brightness. Because typical star, like variable star brightness is usually kind of on a fixed beat, if you will, like a fixed rhythm of brightness, like a fixed pattern. But the the pattern of Betelgeuse is really just a bunch of kind of rhythms and beats. Like, think of it in terms of like light, in terms of light brightness, but they just like overlap, and it's very interesting. And these periods can last as short as a couple hundred days, and some can last like a couple thousand days. So yeah, it really does vary. And then besides that, these well, I'm saying a lot today. But anyways, that was really weird to me. I don't know what I was doing. Just like whatever. But I'm really digressing here. But like the researchers believe that like the overtones and then the brightness cycles are actually indicative of potentially the date that Betelgeuse explodes. And some people believe that Betelgeuse at this point with the brightness is kind of a ticking time bomb, and scientists haven't exactly been able to pinpoint when that's going to happen. But when it does, it'll be spectacular. I'll say that. But anyways, another piece of like evidence, if you will. So first off, we talked about kind of recapping. We talked about the lightness and how it's really peculiar. In that terms, in regards to the pattern. But Betelgeuse is also moving slightly in the sky, so like very slightly. But this also aligns with a kind of a companion star theory, and because Betelgeuse really ever moves so slowly. And if we look at the astrometric and the radial velocity data for Betelgeuse, that kind of corroborates with a smaller body, kind of tugging on Betelgeuse in one particular direction. So it is interesting. But while it's all kind of pointing this way regarding a potential companion star, it's the main challenge is going to actually be observing it, because we have no idea of what we should be looking for. Like if there's like the properties of the star, brightness, size. It's all still very theoretical. So the only way we can do it is through mathematical computation and trying to calculate and predict kind of how big this star should be in relative to Betelgeuse. And we've already kind of got an idea. I'm sure if we use the tug force that's kind of slowly, or not slowly, slightly moving Betelgeuse in the sky. We can use that to kind of estimate how much mass this star has, because mass is related to gravity, and we're trying to figure out what we're supposed to look for, what kind of star, low density, high density. Although from what it seems, it's going to probably be a small star, nothing too big, because it's, like I said, pulling on it slightly, but it should be big enough so that Betelgeuse doesn't kind of cannibalize it and consume it in a collision. But anyways, that's all I've got. Who knows? Maybe we'll either discover it soon, or Betelgeuse will explode, and we'll never know why Betelgeuse was a very weird star like this. Very, very, very odd and interesting stuff. So anyways, that is all I've got for this section. Let's go move on to this week's Sky Report. Alrighty, guys. Welcome to this week's Sky Report. Halloween's coming up, so it's going to be spooky. Except it's not really going to be spooky because the new moon doesn't happen till Friday, but I'll get to that later, which is kind of disappointing because it would be kind of cool if you think about it. If the new moon coincided with Halloween, it'd be a very, very dark night. But anyways, reminder, it's probably the first time I've done it on time in a while, but we are on Eastern Daylight Time. All times reported, unless I specify, are going to be in Eastern Daylight Time. So yeah, like I've said before, if you don't live on the East Coast, go cry about it, go figure it out, do the math. I don't care, whatever. But anyways, let's start out with today, 30th, day before Halloween. So, Cygnus the Swan, it's going to be very high tonight. It's going to be pretty high after sunset. It's going to be shining. Well, actually, no. The main kind of anchor point of Cygnus Deneb, that star will be shining at a magnitude of 1.3, which that'll kind of anchor out the constellation. But besides Cygnus, the North America Nebula, which is kind of I think that's kind of weirdly named, because shouldn't it be like North American Nebula unless it's shaped like North America? Although just the fact that there's a celestial object shaped just like North America kind of makes me feel weird. It just sounds weird, but whatever. North American Nebula can be spotted about 3 degrees east, southeastish of Deneb, and it's a pretty large nebula. It's going to be stretching kind of like 2.5 arc minutes across the night sky when it's at its widest. So it'll kind of contract, but I'll be at its biggest, and you can see it across the night sky, which will be pretty big, and I think that'll be pretty cool. So that's something to look out for today, Wednesday. Meanwhile, on Halloween, if you're trick-or-treating and you're staying out late, actually, no, never mind. Wake up really early. But anyways, Saturn, the moon, Iaptus, it'll be shining with a magnitude of 11, and it'll near a superior conjunction, basically. So essentially, superior conjunction is a term where basically there's a celestial object on the opposite of the sun. There's a celestial object that is opposite of the sun from Earth, but between those three objects, they'll form a straight line. So it'll be like object, sun, Earth, basically, and that'll form a straight line in orbit, in terms if we were looking at kind of a model of the solar system. But anyways, this is located one arc minute southwest of Saturn this morning. And then for Saturn itself, Saturn is actually going to be shining at a magnitude of 0.7 in the constellation Aquarius. That'll happen by 9 p.m. local daylight time, so that's on your clock, not Eastern. But it'll still be on Eastern, but it just depends. And it'll hang about 40 degrees above the southern horizon in the night sky. Anyways, moving on. First day of November. It's actually kind of crazy how how fast this year's gone by. By the time we reach December, I believe that means we'll be on the air for what, like half a year now, something like that. I don't know, but I'm getting ahead of myself. New moon is going to occur at 8:47 in the morning, and since there'll basically not be a moon out, there's going to be kind of a fake dawn, which will be emitted by zodiacal light. I believe that's how you say it. Zodiacal light. Yeah, zodiacal light. And basically, zodiacal light is basically this kind of hazy. Excuse me. Zodiacal light is basically this kind of cone of a faint hazy glow of light, mainly caused by the reflection of sunlight from kind of meteors and meteor particles kind of shining on Earth. And if you really want to see this effect, and I've seen images, it is very cool. I suggest everyone after this episode go and Google that. It looks very cool. It's like one of those things that everyone's going to see. But everyone's going to see. That's the sound right. It's going to be very cool. It's basically the best viewing location is going to be in the eastern sky, simply because that'll be where the least amount of there will be a very small amount of light pollution compared to looking everywhere else, where it's kind of affected by light pollution. But then if you look over there, not so much. That's what I'm saying. Anyways, so yeah, that is basically what's going to happen for the week. For actual times and stuff, we'll start with Wednesday. Sunset is going to occur at 5:59 p.m. It'd be pretty stupid if I reported sunrise, because by the time this podcast releases, the sun will be it'll be midday here, at least on the East Coast. I know where you might live. But anyways, moonrise is going to be at 5:39 a.m. Moonset's going to be at 5:03 p.m. and the phase is going to be a waning crescent. On the 31st, sunrise is going to be at 7:29 a.m. Sunset is going to be at 5:58 p.m. Moonrise is going to be at 6:39 a.m. And moonset is going to be at 5:24 p.m. On November the 1st, sunrise is going to be at 7:30 a.m. Sunset's going to be at 5:57 p.m. Moonrise is going to be at 7:41 a.m. And moonset will occur at 5:47 p.m. And phases, so I believe I said basically for tonight and tomorrow, Thursday, on Halloween, it's going to be a waning crescent. And then on the 1st, it's going to be a new moon. Although, like I said, I think it would be cool if we had a new moon on Halloween. That'd be so cool. It'd be kind of scary due to how dark it would be outside. But anyways, that's what I've got for this week's. This is really a scary report. I don't think it's that scary. Anyways, that's the end of this Sky Report. Let's go talk about some other stuff. Alrighty, guys. So we're now on to what I like I said, other stuff. That is not the Sky Report. Actually, like I said, we're going to continue talking about stars. In this case, we're going to be talking about the discovery of twin stars, twin brown dwarfs to be exact. So to kind of understand the grasp of this story, we kind of had to do a little bit of time, kind of look back at the history. So back in 1995, there was a kind of a parallel race to find the first exoplanet as well as find the first brown dwarf. And they managed to find the first planet. I forgot what it's it was I think it was 51 Pegasi. Yeah, 51 Pegasi b was the first exoplanet discovered. And then following that was the first brown dwarf discovered, which was designated as a Jalezi 229b. These names are, in terms of astronomy, these names aren't actually that bad. They somewhat make sense. But anyways, also to further understand, what exactly is a brown dwarf? Well, brown dwarf is kind of like a celestial object. It's kind of interplaced between being like truly a star and being a planet, because it has the mass but it can't reach like fusion, like hydrogen helium fusion that like characterizes stars as the way that they create energy. Oh well, but usually on wait, why am I like no yeah what I'm trying to say is that the mass for brown dwarfs usually is about like 70 to 80 Jupiters, so like that's the total mass. But the mass is not big enough for them to start nuclear fusion and to fully become a star. So this brown dwarf, Gliese 229b, was discovered orbiting a red dwarf, roughly 60% of the size of the sun. And red dwarfs, for those that don't know, very small, smaller than the sun, like here, but they use so little, they're very efficient. They use so little energy in their fusion process. Like, scientists believe that they've only used like 1% of their total fuel. So, like, I mean, the ideal kind of paradise for human life is for a planet that could support life, and then of course like have that orbiting a red dwarf, so basically humanity can live forever at that point. But anyways, I'm getting sidetracked. That's in case you didn't really understand what a red dwarf is. But kind of the strange thing is that Gliese 229b is kind of on that kind of on the bigger side of brown dwarfs. It is one of the bigger ones, but the thing about it is that it hasn't been ignited, or no, it hasn't been ignited, but the brown dwarf itself is actually very cold. So the kind of the underlying cause that they believe is responsible is that they're actually looking at a pair of brown dwarfs, kind of like two twins. So from previous observations, like the initial ones, they haven't really been able to discover such evidence. And if such a brown dwarf would exist, it'd have to be pretty darn close. And besides that anomaly, there's also the anomaly of the wobbliness of Gliese 229b, as that's kind of a discrepancy. And the only kind of real explanation to explain that would be through, seeing if there were a companion star. But anyways, here we are now in 2024, and guess what? They discovered that Gliese 229b is actually a pair of two twin stars. So it's actually a brown dwarf with a mass of 34 Jupiters, or 34 Jupiter mass, being in mutual orbit with a brown dwarf that had 38 Jupiter mass, or the mass of 38 Jupiters. And this led to the stars. Well, actually, no. This does not lead to anything. But the stars were 4 million miles apart, which, if you look at it cosmically, that's actually very small. Of course, 4 million miles, that's like you go around the planet like 1,000 times, and you would have traveled 4 million miles. But in terms of cosmically and in astronomy, that's actually a very small distance between the two stars, which will explain why we haven't been able to fully analyze this since its discovery. So yeah, there's more research being done, to really fully understand this and understand the properties of these two brown dwarfs and kind of how they interact. Are they like in a binary system? Although from what it seems, I think it would be safe to say that this is kind of a binary system orbiting a red dwarf, which is kind of like its parent star, if you will. But anyways, that's all I've got regarding brown dwarfs and discovering twins. Let's go move on to this week's edition of Astronomy Trivia. Alrighty, guys, welcome to this week's edition of Astronomy Trivia. Before I start off with this week's question, let's talk about the question from last week. I believe that question was, which planet was first mathematically calculated before observed in the night sky? And the answer to that was Neptune. And for those of you that don't know, Neptune's position in the night sky was first mathematically calculated in August of 1846 by Ibn Urbain Le Verrier, something like that. Urbain Le Verrier. It's a French mathematician, basically, who calculated that. I guess it's Urbain Le Verrier. And then just a month later, at the Berlin Observatory, Johann Gottfried Galle was actually the first person to he did not eat Neptune, observe Neptune in the night sky on September 23rd, 1846 at the Berlin Observatory, which I don't think still stands. I think there's a monument there for it, but they don't do much. But anyways, enough about Neptune and the Berlin Observatory. Let's go into what this week's question is. And this week's question is it's less on the astronomy. It's more of a fun trivia question. But anyways, whose middle finger can be seen on display in Florence, Italy, as they used the finger when met with opposition from the church? Okay, I'm going to read that again. That was a very long question. Whose middle finger can be seen on display in Florence, Italy, where they famously used the finger when met with popular opposition from the church? I'll let you guys think about that. Like I said, put a poll out on both YouTube and Spotify for the respective audiences to take a hit and try to figure out what the answer to this trivia question is. But anyways, that's all I've got. Let's go close out this episode. Alrighty, guys. This is the end of this week's episode. Next week, we're still on normal scheduling time. Nothing new. I will try to get... No one was available to do an episode of the bonus podcast. Some people I would like to get on. Some people I would like you to meet. But they weren't available, so no episode next week. Hopefully we can get one... not next week. No episode this week. There might be an episode next week, depending on availability. But we'll just have to see. So, yeah, and then the regular show, regular song and dance on the same schedule. So, yeah, if you enjoyed this episode, give me a like and subscribe if you're on YouTube, or follow me on Spotify to, support me. I really appreciate all this support, once we grow, it can only get better, that's kind of the dream, if you will. To kind of increase content, maybe new segments, maybe actual interviews with people in astronomy. But yeah, anyways, that is all I've got. This is Michael signing off.